Our lecture today is about enzyme activity, kinetic and inhibition. Actually, this lecture is like a short note on the enzyme. Just the names, the nomenclature, some importance of the enzyme. We don't have time to talk about the enzyme in detail. Before change the module, the enzyme lecture was about 10 lectures, 10 hours. Nowadays, 1 hour, just 1 hour. Give you some information, some important information, which may be useful in your course of this module. The aim behind this lecture is to know what's enzyme, what's the effect of the enzyme in our body, and the chemical reactions, discover how reaction rate vary from one reaction to another, and depend on which, the substrate and the product concentration. Start defining some kind of what is Vmax, so that is Km, just a few not. How you analyze, how you measure enzyme, how you interpret your result, and describing how this enzyme is regulated normally in our body, and from the clinical point of view, how they are inhibited or how they are activated for the clinical purpose. Nearly all the chemical reaction in our body is done by a specialized protein which is called enzyme. So, how you define enzyme? It's a protein used to catalyze chemical reaction in our body. There are thousands, millions of chemical reactions that's done in our body. All of them is done by enzyme. Nomenclature, how they are named, usually by adding the suffix ASE to the name, just by adding ASE, you know that this name is the enzyme. The name is derived usually from the substrate that act on, for example, lactose or lactase enzyme act on the substrate which is lactose, or galactase act on the galactose, and so on. The other substrate derived from the substrate, the name, and adding the ASE, lactase, just adding the ASE, which act on the lactose, converted to glucose and galactose, or derived from the reaction that they are catalyzed. For example, DNA polymerase, which polymerize equated to form DNA. Carteliano, name, the substrate issues, yeah, the name or reaction issues, usually. You have 6 main groups, for example. 6 main groups. I don't know, 4 of them is omitted from this slide. So, first of all, traditional enzyme, depending on the types of the reactions that they are catalyzing. Oxidoreductase, which transfer electron, transferase enzymes, which transfer carbon, nitrogen, phosphate, hydrolase, just adding water to a bond, hydrolyze the compound to compound, lyase, just adding or removal of a group to form a double bond, and isomerase, which are these are examples of oxidoreductase, just transferring electron group. Here, transfer a group, for example, this group, methyl, gel, ester, any groups. Hydrolase just adding water, H2O, to a compound, hydrolyze it to product. For example, this are example urea convert other ammonia. Lyase, catalyzed cleavage of a bond between carbon, sulfate, carbon, nitrogen, and isomerase enzyme just removing a group from one side, add it to another side of the same molecule, produce isomerized molecule. They are the same, but the side of the attachment of the group is different. Ligase is just adding of a groups to a molecule. For example, here pyruvate carboxylase adding CO2 to pyruvate produce oxaloacetate. So we have 6 main groups of enzyme: oxidorreductase, lyase, ligase, transferase, isomerase, and so on. Property of the enzyme. What are the property of the enzyme? Just simply, the property of the enzyme. تفاصيل جزء من property enzyme. Or simply, چندانی که دیگری بسن. Virtually all enzymes are protein. Most of them, almost, they are protein. And some of these enzymes need another compound in order to be activated or inhibited. These compounds are called either cofactors, which are inorganic ions such as chloride, manganese, magnesium, calcium, needed for the reaction to take place. Or coenzymes, these are organic substances, for example, coenzyme A, vitamins, and NAD, so many other fats, so many other organic substances. These are cofactor coenzymes. Sometimes they are tightly or covalently linked to the enzyme protein, attached to the protein. And that one is called orthotic group. So enzymes usually are protein and sometimes needs cofactors or coenzyme in order to catalyze the reaction and at the maximum velocity. Other property of them are highly specific to the substrate. Enzyme increase the rate of the reaction, so the enzyme with times more substrate. Enzyme are differentiated after the reaction has occurred. These are the 4 main properties for the enzyme. How do enzyme work? Enzyme work by lowering the activation energy needed for reaction to occur. Binding of the substrate, substrate. Binding of the substrate to a specialized area on the enzyme, which is called the active site, increase the local concentration of the reactant, and also stabilize the formation of the high energy transitional stage. If we look at this picture, these are the enzyme with the enzyme. So, the time is decreasing, the amount of the substrate also is decreasing with the enzyme. Without the enzyme, we need more time. The transitional state will need more energy, more time, more substrate. What is the active site? Enzymes are protein, so it contains a sequence of amino acids that are linked by peptide bond. A few amino acids on a specialized area on the enzyme, call it active site. So active site contains few amino acids making a sequence on a larger molecule, which is the enzyme. Binding of the substrate to the active site is an important determinant of the specificity. enzyme here صدها amino acid branch amino acid active site اگر active site amino acid texture enzyme işlemi. So the specificity of the enzyme depends on the active site. Some enzymes have one active site, some others have many active sites. It depends. Finding of a molecule or a substrate to a complementary shape to the active site will be able to bind to the enzyme and bind to the substrate. The shape, the size, the strength of the amino acid of the substrate is important to be recognized by the active site of the enzyme. It is just like a lock and key hypothesis. The substrate held in the active site by multiple weak points. They are binding by multiple weak points between the amino acids. In this part of the enzyme, often binding of the substrate result in the change in the shape of the enzyme to enhance more binding. It's also called inducing peak hypothesis. هي شكل معنا أمشوا hypothesis كثير مثلا يعني تفاصيل والرجاليز ولا بس أنا أعطيها اشتكي بناي كيلوكو اشتكي بناي inducing peak hypothesis. Create by power which services. By speakers. I'm looking exam So this figure show you just a schema of the enzyme. There is a specialized area of the active site. The shape of the substrate is conformity to the active site and is equal to planning traditionally. We have two main things here. Okay, we know that enzyme catalyzes reaction. So how do we know that this reaction is take place in our body? How we measure enzyme activity, how we determine the loss of the enzyme, how we determine the excess of the enzyme. Simply, first equation is a Miklos-Menten model for the enzyme catalyst. This model shows you the enzyme plus the substrate produce enzyme substrate complex. Later on, enzyme and the product is produced. From this equation, we know this reaction is take place or not. And let's say I'm okay. نزيد لدشنا زاني هاي يعني أجر هاي يشكانا أجر يشكي مظبوط يعني وأنتكي زوريا كان شون في كان سبسيت في كان برودكت في وكيف زاني هو نزيمان أجر برودكت نبو for example because like لسه غير بارافيت وبارافيت ما نبو أنا ماشي أو نزيماني كيش بارافيت هيش نيل هاي كي كامل ما كان شيء زحمة الآن كان يشوفوا زمانية ويسمعوا My question again, initial velocity Vmax times substrate concentration over the Km plus substrate concentration. Vmax here is here the maximum velocity. How much substrate is needed to reach the maximum velocity of this reaction? While Km, how much substrate is needed to reach half of the Vmax, half of the reaction? From this equation, we can calculate So Vmax, Km, substrate concentration, velocity. هيك لما unknown bit, باقيات known bit, وين unknown bit. Simple. This figure show you what is half over Vmax, this is the Vmax. Half over Vmax is the Km. At high concentration of the substrate more than the Km value, the velocity of the reaction is a zero order. That is, it is constant and independent of the substrate concentration. Total concentration is substrate to zero, substrate ki ijna right? At so zero order. While at low concentration of the substrate concentration less than the Km value, the velocity of the reaction is first order. That is, it is proportional to the substrate concentration. Substrate concentration the ودو ده زي كي سيري كي أنا جاني ما بكالوري reaction ده تيجي كالوري كمثلا the glucose measurement start from peak to the dark red. The peak is the super low dark. At glucose تيجي overall peak كارو red dark red. So it depends on the substrate concentration. The more easier plot in plot use the Nichols-Mitten equation in order to make a plot, and from this curve, it's not a curve, it's a plot straight line, we can estimate, we can measure the Km and the Vmax and the concentration of the substrate. Another basic account. أنا بيس كي measurement enzyme لما نوها لنهاية procedure بس أنت تطلع شتيت لو حصيل بتاعتك أمين. Inhibition of the enzyme. How enzyme is inhibited in our body? By the way, why we inhibit enzyme in our body? Which inhibition? Physiologically inhibited enzyme that had issue. أنا فوضى دروس سبب يجي يعني فوضى جاجري stop. Okay, PST dash enzyme application. Email. No. The physiological life. But from the clinical point of view, sometimes we need to inhibit an enzyme in order to prevent the production of the product. The product is a very dangerous one. And the many future, the reaction stopping, yakut chemical, okay? Which product is very dangerous. Inhibitor can be seen on the vaccine, irreversible inhibitor. Here, the product or the molecule or the drug, for example, bind covalently to the enzyme molecule to destroy the enzyme fraction. So simple example here, cancer cell. Cancer cell, cancer listen, cancer cell cancer cell irreversible. The stop the reaction until the cell is coded cancer cell because so a reaction the cancer cell depends on it, you need to stop it completely. It's called irreversible inhibitor. There are so many drugs used in the anti-cancer therapy. Second types of inhibitor is called reversible. Reversible inhibitor which is of two types, either competitive or non-reversible. And energetic That's the basement inhibitor reaction. Or not in the solar inhibitor. Chemically. Yeah. Now it was the reversible. This is also of two types. Competitive one bind as the substrate of the drug bind to the active site, affected the Km value, not the Vmax, can be overcome by increasing the substrate concentration. Look at this figure. With competitive inhibitor, there's no competitive inhibitor. Again, curvature shift to the right, and correction velocity, the Km value is increasing. So when the Km value is increasing, what does that mean? We need more substrate for this reaction. It's no inhibitor. چون overcoming androg اگه تو در من یکی ها و نخوشه سری پیگو ایشی که بوده که زیاد لحدی خوی بوانی زیاد لحدی خوی بوانی تیوه کسی میداره این بکو انتی هایپرتنسی دراگ کن معنی که بوزخ بکنی سری زوی دوازانی یا دوزگی که مگه یا سبستریتی که زیاد to overcome this competitive inhibitor. The non-competitive inhibitor, here the drug or the inhibitor affect the Vmax, not the Km value, so it will not be overcome by increasing substrate concentration. Substrate hatching medium is the acidic tenant. The Vmax is come to the door. Reaction rate is slow to the high to the door. وإذا ساعات كهرباء يستخدمون درمانة لا شيء لكن ساعات كهرباء هو مانتي برودكتي تدرس به كشتة كنت معناته المسألة ستستوبك اشتكي يومي تقولش بداية سيرش so it affected that Vmax not the Km value is the same here and here so it will not be affected by the substrate concentration. How enzyme is regulated in our body? Usually, there are two main forms of regulation: the amount of the substrate and the amount of the product. Generally, changing the enzyme conformation. These are two main mechanisms for regulation of the enzyme. First of all, allosteric control. Mechanism or ways to control an enzyme. One of them is called allosteric one. There is allosteric enzymes are multi-subunit enzymes that contain more than one active site for the substrate. Enzymatic rate allosteric control inhibit reactivation. Usually they contain multiple sites. Maybe there is a specialized site for allosteric substance, or the same active site of the substrate used for the allosteric substance. This is caused by positive cooperativity. The binding of substrate to one active site enhances substrate binding to other active site. I mean, it's like multiple sites here. The substrate will show you Hani active site again, you have more substrate. You take more substrate and the reaction velocity is increasing. Well, here are 6 seconds. How do you Japanese? Here. طبعا هم انزيم يكون رجع كونفورمات allosteric. هم enzyme allosteric enzyme. If you look at this picture, if we suppose this for the substrate, and this triangle is for the allosteric substance. Allosteric substance is very important. أنا أشتغل موديل فكرته هو substrate activator. Here inhibitor, specialized site for the inhibitor. Activator, specialized site for the activator. And for the substance also there is specialized site, usually one. But sometimes the same active site for the substrate can be used by the allosteric substance activator or the inhibitor. If there is activator, so the sigmoidal curve is shifted to the left, symmetrically. If there is an inhibitor, it will be shifted to the right. How about it? Non-stoppable. How about it? Another way of regulation is covalent modification. There are many different types of groups that can be covalently attached to the protein or to the enzyme via amino acid. For example, أشرح محاضرة نص ساعة. شلون تحمل الإنسان؟ نص ساعتين قريب. جلوت أن تأكل. ولا يمون Groups: phosphoryl adenine acyl uridyl methyl. Adding of this group to a molecule either activate or inhibit. For example, phosphorylation, adding of the phosphoryl group. These are the most common way of adding a phosphate group to a molecule or enzyme. The phosphate is often enzyme usually activated by protein kinase. Any kinase enzyme. Removing the phosphate group from the enzyme by phosphatase, it will be inhibited or inactivated, usually. Usually, أجل phosphate إضافة activation هنرجع inhibited, inactivated. Another way of controlling or regulating the enzyme is proteolytic activation. Some enzyme is produced as a larger molecule, which is called a zymogen, for example, pepsinogen. Larger molecule, larger sequence of amino acid. A part of this larger sequence is removed to make the more active form protein. A protease enzyme. For example, here, pepsinogen convert to pepsin. Pro-pimidinoprotein convert to acetyl, adenocorticotropic hormone. So many examples now. Yani, poco precursor, usted substance pionanus activation they active. Particularly activated. Example here, clotting factor. How the amount of the enzyme is changed in our body. How they are changed. There are two main ways for changing the amount. Either regulation enzyme senses how much enzyme is synthesizing in our body, producing in our body, which is depend on the product, which either increase or decrease of the rate of transcription for the messenger RNA, the messenger protein and messenger RNA, ribosome, this protein could be enzyme, or the degradation of the enzyme or protein, clearance from our body. It can be inactivated by heavy and cleared from our body, either from the urine or in the stool. Amount of enzyme كدرس كده لذاش معنا الماضي يشجعكاتو وخوي منتو يشجعكاتو وخوي منتو جاكو هدرس كاتو أمي زمان ليش معنا هرب منتو ناكل amount of enzyme كذا ده رجيك شريبه degradation clearance from our body. Metabolic pathway, how they are regulated. What do we mean by metabolic pathway? Metabolic pathway, I can show you.
oxidation.
Glycolysis, oxidation. Zor. Basically, lipid glycolysis, lipid formation, carbohydrate glycolysis, carbohydrate formation, glycolysis formation, and for the protein degradation, protein catabolism. Metabolic pathway. Strong controllable substrate product. As a indicator ammonia. Feedback inhibition in product of the pathway inhibit its own regular synthesis. Product like a changes can inhibit the first enzyme. Feed forward activation increase the amount of the initial substrate. When the mechanical substrate now, the activation pathway can be in order to catabolize the product to make the basic molecule, which is glucose, amino acid, and so on. Here there is an example for the enzyme in our routine, main mechanism which regulate the blood clotting cascade. Inactive zymogy present at low concentration. Most tissue factors are present in inactive enzyme and molecular we for the clotting to occur. It is present in our circulation, but in a very small amount, in order to prevent initial or initially accidentally the clotting. And it is obvious, as a clotting royal, obviously the world she reminded to she spoke about she higher result. Look at the piece there is damage to the blood vessel. The rate of the synthesis is increasing and the clotting occurs. Amplification of the initial signal, damage to the blood vessel initiate a cascade of activation resulting in the formation of insoluble fibrin clot. Feedback activation by thrombin, activated contact, initially amount of current. Signal way activation. And the third way is activation by thrombin. When the product is produced, it will inhibit. Activated thrombin enhance the conversion of these factors 5, 8, and 11 to activated form, and all the cascade occur later on. An example. We have two main pathways to activate the factors in our body in order to produce the fibrin, the end results. Result damage with extrinsic factor. This factor is activated, and the end result, the fibrin produced. Intrinsic pathways are some factors, positive, which activate. There is a cascade. I'm activated. Agar iki plan faktörlerine ne biçiyor? İki plan enzyme, iki plan proteinlerine ne biçiyor? Evet. Müşküle akıllılarda müşküle. Example, blood clotting, bu hemofili. Clotting. Şu içeriğine bir clotting. Zit is ook Turkish. İlla faktörüyle güzel Okay. Last topic. We know all the information about enzyme, the importance of the enzyme knowledge. Okay, how we measure it? How we measure enzyme in the laboratory? We have enzyme assays just like simple chemical ways to measure the enzyme depending on the micrometer equation, and this is depend on the substrate, on the product. Some product does what, some substrate does what, velocity, time reaction, management, community, for example, enzyme, hair, nia, genetica, خاوة, سريعة. Another way, these are examples of the enzyme algorithm, the measurement of them. They are important. For example, AST, ALT for the liver damage. So when you suspect there is liver damage, you send the patient for the measurement of AST, any transaminase, and ALT, ALP, GGT. Acid phosphatase, prostate cancer, CK, kinase for myocardial function, lactic dehydrogenase for also for the myocardial function. There are so many examples, thousands of examples. Measurement of these enzymes is important clinically. So the first way is simple chemical procedure. Just you can measure the substrate amount and the product amount. Another way, immunological technique, you design, you produce a specialized antibody in order to recognize the specific enzyme in our body. Antibody can be generated that are highly specific for the particular protein. This specific importance allows for the identification of particular protein in our body. فبالتالي انزيمات معينة جدا هي antibody بتستفيد كإنزيم الناسي. XCP حاجة couple in acid measurement. Another technique is Western blotting. Western blotting, you separate the protein on a membrane, cellular system membrane, by electron transfer. Transferring protein mechanically, bound to cellular system. And after separation of the bands of the protein, you add specialized antibody to this band in order to recognize that protein or that enzyme of interest. That is a requirement. Chemical assay, immunological test, and Western for measurement of the enzyme. Example of the immunological assay is ELISA. Spas.